Hello, welcome to 1.2, just a bit of a recap of all things RAM, ROM, and virtual memory related. This is session 1.2, and let's get stuck in. So, this is a video lesson. Surprise, surprise, you're watching it on YouTube. And I would ask you, as I always do the suggested thinking. Make sure you hit those pause points, pause the video, pen and paper handy, jot down the things, do the activities. That's how this stuff's going to stick. Don't just roll through, don't skim along the video. I'm going to say it every time because people are doing it. I know because I can read statistics on YouTube. So this is from 1.2. We're going to be looking at primary storage. We're going to look at RAM, ROM, the purpose of both, and virtual memory. This is quite a quick one. Don't expect you to be on this one for too long this week, but it is just something that when it crops up, we need to be getting every single mark available. It's too easy to be failing. So let's get this embedded and let's get it concrete. So, specific objectives here. It's the purpose of the different types of core memory that are in a computer system. Things like what's the need for the primary memory, what's the purpose of RAM, what's the purpose of ROM, and why do we have virtual memory. A little bit of extension for those of you that want to use some of that extra time today to kind of look at stuff that's a bit more linked to A level, but keep those aspirations high. If you find this really easy, maybe just a little bit of a scout of this would be good. So understanding how memory is managed by the operating system in terms of using paging and segmentation. So I'll talk about that at the end for those of you who want to have a little fertile and go and have a look at that. So, quick refresh. Little question for you. CPU's got access to several types of memory, and they vary in their distance, size, and speed compared to where their location is in compared to the CPU. On a piece of pen and paper here, can you jot down all the kinds of memory you know, and maybe in a diagrammatical way, which ones are closest, which are biggest, which are fastest in relation to the rest of the computer. So pause the video now and you're back. So you should have something like this. The very fastest piece of memory available are the registers, which we learned about in 1.1, with their specific jobs in that fetch, decode, execute cycle. We then got the cache memory, which we'll talk about in a second, which is actually on part of the CPU. Then we've got our RAM, which we're talking about today, and then we've got an example of secondary storage there, a hard disk drive, which is going to have all of your applications on and stuff for long term. So the further away we get away from the CPU, the bigger the storage and the slower it is and probably the cheaper it is. So that's the relationship. Nice and easy. Make sure you know all of those and the kind of how they link together there. So cache memory then. So this is the small amount of memory that's available to the CPU. It's part of the CPU, and what it's doing is it's holding temporarily those instructions that it's being given to do. So things like add this, subtract this, store this, load this. It's those kind of instructions. And the control unit's going to be the piece of the CPU that's really going to be kind of interacting with the cache, if you see what I mean, grabbing what it needs, and then therefore then requesting the data from the RAM after that. So more cache means you've got more faster memory available to the CPU. It does come in like levels, so you have level 1, 2, and 3. Just try and think of it as the smaller the number, the smaller the memory, and that relationship usually is the smaller it is, the faster it is in terms of the memory inside the computer. So L1 cache is really fast, and L3 is fast, but not as fast as L1. There's a bit more room, and that's kind of it. There's some lovely, complicated pictures which you don't have to commit to memory, but I just thought they looked nice, colourful. Woo, enjoy. Primary memory then. So I've given you the first bit. So there is memory that the processor will access first and directly. I want you to pause the video and put anything else you might know about primary memory. Not an easy question, probably one you might struggle with, but just see what you can kind of root out of your mind there. So pause video now, and you're back. So things like this, like I say, this is not the easiest stuff. So if you got these, great, well done. So it allows the processor to perform read and write kind of commands to data, which is kind of what it does. It's like bread and butter. Allows the process to access running applications, those that are running, and there it consists of the two elements RAM and ROM, which is probably the bit you might have said, because linked to what we've been talking about, it seems obvious. I was going to tell you about RAM and ROM. They are both primary memory. So RAM. So this is textbook stuff. I want textbook definitions for this. So pause your video and tell me the purpose and the characteristics, that's both of them, of RAM. Off you go. Pause. And you're back. So you should have said it was random access memory. It's primary memory, we know that. Volatile. I want to know what that word means if you're going to drop it. This is a characteristic of RAM. Volatile means that if the power is lost, then so too is the data that it was holding. So if it's got a big old document you've been working on and you pull the plug out the wall, RAM goes, see ya, and drops it. Boosh, it's gone. Holds all the actively running programs. This is its purpose. RAM holds all the stuff that's on your screen. So if you can see it, touch it, smell it, and it's on the screen, that is being held in RAM. The most obvious example of this is the operating system. So if you're given this question, what's the purpose of RAM? Always say it holds all the actively running programs, and give your example as the operating system. That's it. That's RAM. Easy. So let's rinse and repeat this time, and let's go in for ROM. Read-only memory. I've forgotten to put my pause symbol because I forgot to copy paste it. Doesn't matter. Pause this video and write down everything you know about ROM, please. Characteristics, purpose, go. And you're back. So it's non-volatile. We could have guessed that. We flip it. This one holds data. It doesn't forget. So even in a power down. It cannot be overwritten by the computer. Okay, that's quite important. It's read only. It's the clues in its name. It stores what system critical software. So a good example of this is going to be your startup routine. So when you fire up the machine, there's got to be something stored that's not forgotten about how to start the machine up, and that could be like your BIOS. So that will fire up that's responsible for firing up the computer, the kind of black and white screens you see when you turn the machine on. And that's ROM. We're steamrolling through this, aren't we? So virtual memory then. I'll let you have a little think. Trying to just have a little think. What was virtual memory? So invoke the memory spirits and see if you can just have a little think. And you're probably along the lines of, this is the one about when you run out of room, what happens? I'm going to tell you what happens. So what happens when you run out of RAM? Well, you're probably going to get a nasty crash. So you're having your all-time PB, playing Fortnite, Overwatch, Minecraft, insert current game here, and you're eating up that memory, and then your computer starts to get sluggish. It starts to get, I can't handle it. There's not enough RAM. I haven't got enough resources. I've just totally just the RAM. So what can we do? Well, we can use virtual memory. So virtual memory is where the operating system uses part of the hard drive. That's your secondary memory. Remember, it's not primary. It's a bit slower, bigger, but slower, and it just kind of moves all the things out of RAM that you're not really doing. So that big game you're playing, well, there's some other things you've got open at the moment, some documents and some web pages and all this other stuff. You're not really looking at that right now. You're just playing this game. So it moves all of that stuff, all the inactive processes and applications, and dumps them on a reserved piece of the hard drive. So by doing so, you have freed up some room. So the RAM's got a bit more flex. It can start to kind of work its magic again. This is going to slow down your system a bit, because eventually you're going to probably close the game and suddenly want all those things back that are on your screen. Well, they're not ready, so the computer's going to have to pull them back from the hard drive, and this could cause a bit of delay, a bit of lag in the system, really, as it tries to kind of sort itself out by moving. It's called disk thrashing, where it's trying to move stuff off the hard drive back into RAM so that it can be used by the CPU. So the more RAM you've got, the more things the CPU can handle at the same time. So it can like juggle more balls, so to speak. So that is our virtual memory. Nice little story. There's a lovely little kind of journey you take through when you explain that, but it's worth a lovely amount of marks if it pops up on an exam paper. So commit it to memory, please. Make sure you know the little story and weave it through. If you can't remember it, rewind me, watch me again. I'm worth it. So just do it. Make sure you've got this down. And I mentioned there'd be some possible extension on this one because it is short. So, um, who's in control of that CPU? And who's doing that? Well, it's the operating system. All right, we know it's the operating system. So how do you think the OS knows what to do first? So if it's got all these jobs to do, how do you know what it's got to do first? And how does it know what to do when something more important comes along, like something urgent? And how do you stop the CPU doing what it was doing because there's more urgent things come along? Well, this is what you learn kind of at A level. But if you're interested and you want to take a look at this, maybe go and have a look at what two things: scheduling and also what we call paging and segmentation, which is a way of managing memory. This all comes up on A level. It's worth looking at it if you think you're at the top of your game and you can eat this up for breakfast, but that's totally up to you. So we've just done 1.2, which is the primary storage memory section. I'm sure you found it nice and easy. Now, until next time, take care, enjoy, stay safe. Ta ta.